All right, hey everybody. So we're going to do a little bit of a review on the spliceosome. So again, as we're going through this splicing, what we're going to look for is the exon at the 5 prime, exon 1 at the 5 prime end, exon 2 at the 3 prime end of this molecule, and then the intron in the middle. So if we look at the reaction, we've got to have the branch point A and its 2 prime hydroxyl group. The electrons from that hydroxyl group are going to form a new bond with the phosphate at the 5 prime end of the first G of the intron. When that happens, there will be this new phosphodiester bond, so that's a transesterification reaction. When this phosphate from the G gets attached to the 2 prime hydroxyl from the A, then the bond between the 3 prime hydroxyl on exon 1 and the 5 prime phosphate on this first G of the intron gets broken. So that's step 1. And then step 2 is the 3 prime hydroxyl from exon 1 forms a new bond with the 5 prime phosphate from exon 2. As soon as that happens, then the bond between this 5 prime phosphate on exon 2 and the 3 prime hydroxyl on the intron that you can't see, that bond gets broken and you end up splicing together exon 1 and exon 2, and the intron with its lariat structure goes away and is recycled. So let's go through. We're going to skip that slide. Just as a reminder, the 2 prime hydroxyl group is going to form, so this is going to be the branch point A, is going to form a new phosphodiester bond with the 5 prime phosphate of the first G of the intron. Okay. So again, we're going to go through all the pieces. We got U1, U2, U4, U5, U6. There's no U3. Uh, each one of these, you can think of them as complexes. So it's part RNAs and part proteins, and those both come together to make a functional U1 or U2 or U4 or U5 or U6. Okay, so there's a whole bunch of pieces in this, and we're going to get into how each one of these spliceosome components forms specific base pairing between the spliceosome component and a particular piece in the RNA that's going to be spliced. So we're going to start with, excuse me, in step 1, we're going to find the branch point A and then the 5 prime exon boundary. All right, so U1 comes in, it finds the 5 prime end of the intron. And if we move this intron or fold it around on top of the 2 prime hydroxyl group, then U1 is going to find that 5 prime GU of the intron. U2 is going to find the branch point A in the surrounding region. The way it does that, both of these actually form hydrogen bonds with the surrounding sequence. So U1 finds the 5 prime end of the intron. U2 actually finds all the sequence surrounding that branch point A. And because all of the other bases surrounding that A on the intron have a hydrogen bond with U2, it actually forces that A to be poking out just a little bit, which means if we go on to the next step, that A is now primed to form a new bond, phosphodiester bond with the 5 prime G. Okay, before that can happen, we already have U1 and U2 on this complex. We're going to have U4, U5, and U6 come in and kind of switch places with some of these. So U4, when it comes in, it's going to grab U1 and go away. Before U1 goes away, U5 kind of picks up and binds the 5 prime end of the intron. U6 is associated with U5, and U2 stays where it is. So we had U1 and U2 all by themselves. U4, 5, and 6 come in. 5 and 6 do a little switcheroo with U1, and U1 and U4 head up and leave. Okay, so now we've got a bigger complex between U5 and the exon and the intron that we'll get to in just a second, and U2 and U6. All right. So not only is this thing folding around, but now if you look at it, exon 1 is now from this top is going to fold around and do some crazy acrobatics. So now the 3 prime end of exon 1 is lined up just next to that branch point A, and the electrons from this 2 prime hydroxyl on the branch point A are now going to, they call it attack. They're going to form a new bond with the phosphorus of the phosphate group attached to the 5 prime G of the intron. So as we're going through this again, you've got to be comfortable with which side of the molecule is the 5 prime and 3 prime end of the exon and the intron and the other exon, right? Okay, so step 1 is to get the branch point A exposed. Step two is to get U5 and U6 on the intron that needs to be spliced out, and then form that new bond between the 2' hydroxyl of the branch point A and the 5' phosphate of the intron. All right, so that happens. Once that happens, now that phosphate, the phosphodiester bond between exon 1 and the 5' phosphate of the intron, that now gets broken because now the 5' end of the intron is covalently bound to the 2' hydroxyl of the A. Okay. Once that happens, the only step left is to form a new bond between the 3' hydroxyl of exon 2, excuse me, exon 1 and the 5' phosphate of exon 2. So all it needs to do is do something similar to what happened before, is the 3' hydroxyl is going to form a new bond with the 5' phosphorus of exon 2. And as soon as that bond is formed, this lariat structure is going to not be attached to anything. U1, excuse me, exon 1 and exon 2 will now be spliced together, and splicing is now complete. So once again, as soon as that second bond is formed, these two exons are now spliced, and the intron is in the shape of a lariat structure. There's still the bond between the 2' hydroxyl group of the branch point A and the 5' phosphate of the 5' G of the intron, and this will go and get degraded and recycled in the cell. So this little bit is just showing what the 2' hydroxyl is going to be up to. All right, so the 5' phosphate so this is the 5' phosphate at the beginning of the intron and moves around. We've got this 2' hydroxyl on this is the branch point A, so this is the 2' hydroxyl group that is going to be attached to the, sorry, I just got this flipped around. So look at this correctly, unlike what I did. This is the 1' carbon. It's the one that's attached to the nucleotide, to the base. This is the 5' carbon attached to the phosphate. And we've got the 2' hydroxyl here that's going to be attached to the 5' phosphate. Then we have the 3' phosphate that's attached to the rest of the RNA just next to the branch point A. All right, so hopefully that helps. You're welcome to draw this out or do whatever you need to do or watch this as many times as you need to, but I hope that was helpful for you. All right, stay tuned for more.